Hello everyone, welcome to my project presentation. I'm Xiangzhu Yan. My project is about League of Legends match outcome prediction. Here is a problem statement. The goal of this project is to use linear programming to predict the outcome of League of Legends matches. There are three steps to implement this. The first step is data collection. The second step is LP model construction. And the third step is solving LP model to obtain the win rate for each team. About League of Legends. League of Legends is a multiplayer online video game developed and published by Riot Games for Microsoft Windows and Mac OS. In this game, players control characters called champions, who each have a set of unique abilities. In a match, two teams of 5 players compete to destroy the enemy's nexus, which is guarded by enemy team and many turrets. Each team aims to define its own structures and destroy the other team's structures. In the map of League of Legends, there are 3 lanes, which are top lane, middle lane, and bottom lane. It's also worth to mention that there are many regional and worldwide League of Legends tournaments held every year all over the world. About 2020 World Championship. 2020 World Championship is the most important League of Legends tournament. 32 selected teams from all over the world fight for the championship and a prize of $1 million. The goal of this project is to predict the outcome of matches in 2020 World Championship by linear programming. About data source. Since there is a big difference between different patches of League of Legends, we only collect data from matches in the group stage. There are many data can be collected from a single match. For example, 10 champions picked and 10 champions banned, and the side, such as red side and blue side. The following link is where I collect the match information. Here is an example of my data source. In the left picture, we can see general matches information such as number of games, average game duration, and so on. In the right picture, it shows details of a single match such as champions picked, champions banned, and who wins. Here is I used the linear regression to solve this problem. This is a model from lecture slide, just like the apple tree problem we solved in class. We're given x, which stands for the data I mentioned in previous slide, and y, which stands for the outcome of the game. My goal is to find the beta to describe my LP model, so I can calculate the outcome after I know the match data. Here is the implementation of x. X stands for the data of matches. Specifically, in this project, X stands for 10 champions picked and 10 champions banned. So all I need is to collect the ID of champions and sort them into correct order. To do this, I use an array list to store the name of all 150 champions. When I want to get the ID of a champion, I can call the index of method to a release and get the champion ID easily. Those IDs are sorted as the following orders: our picks, enemy picks, our bans, and enemy bans. As a result, our X will be a matrix with a column of 20. Here, for the implementation of Y, I refer to a software called kernel KI. The kernel KI is a precise winning rate prediction software, which is based on big data analysis and matrix modeling. The kernel KI can make highly accurate predictions on the outcome of the game and the winning rate of each team. In this project, I used kernel KI's prediction result as our Y matrix. From the picture above, you can see the win rate predicted by the kernel KI. The win rate of G2 is 53%, and the win rate of Team Liquid is 47%. Here is my LP model, and it's really similar to the apple tree model in the class. To solve this LP model, I use the Octave, and these pictures are screenshots of my code to solve this LP model. After solving the LP model, I obtained the beta, which can be used to describe the relationship between X and Y. And I used the beta to predict the outcome of the latest game. The picture in the left shows the data of the final game of 2020 World Championship. I get the ID of champions in the picture and sort them into the correct order and multiply them by beta. And finally, I got my own prediction, which shown in left column of the table, and the right column of the table is the exact win rate calculated by the kernel KI. Comparing two sets of predictions, we can find that Game 1, Game 2, and Game 4 are nearly the same. But those of Game 2 differs a lot. After analysis, I found that the problems come from the champion picked in Game 2. One of the champion picked in the Game 2 was never picked in any of previous games. Hence, this will lead to a huge prediction deviation. Issues and prospects. This project cannot handle special cases, such as when a champion who has never appeared is picked. Unfortunately, this happens. Also, this project only considers 20 parameters, 10 champions picked and 10 champions banned. We can add more parameters to increase the accuracy, but we also need to face more computation and even remodeling problems. Alright, thanks for watching.